Hello, Math 200 students. This video is going to go over a practice assignment that will kind of review a lot of what we've done in this class and also help you to get ready for the online standardized assessment. I would recommend that you actually try this practice assignment on your own before watching this video. That way you can just watch the video for what you need, and it'll help you better that way, I think. But let's get with it. So number one, what I would do on number one, probably that x is greater than 10 in a normal distribution given the mean and standard deviation. I would just go to my calculator, go to second distributions, normal CDF. We're talking about being greater than 10. So that means the lower limit is 10 and the upper limit would be infinity, or 1e99, with mu being, I think it said 9.5, and I can't remember what they said the standard deviation was, 1.4, and that'll give you your answer. So 0.360 would be a good answer for that question. Number two, we're trying to find the 96th percentile. Okay, it gives me a mean, it gives me a standard deviation. We're trying to find the 96th percentile for that normal distribution. So I would go to my calculator. I'm given the percent, so I'm not doing normal CDF. I'm doing inverse normal. If I'm given the percent, I'm trying to find the value that's associated with that percent, then that's an inverse normal. So the area that I'm looking for 0.96 of the area, or 96% of the area, to be to the left of the value I'm looking for. So I'm going to do a left tail with 96% being lower or to the left of the value I'm looking for. What did it say the mean was? The mean was 22 and 0.25. 22 for the mean and 0.25 for the standard deviation. Doing it this way would be a left tail. I could also do a right tail, and then the area would be 0.04, 4%. That would accomplish the same thing. So 22.44 looks like a good answer here. All right, so 22.44 would be a good answer to number two. All right, number three, probability. We're talking about tossing a coin 7 times and getting exactly 2 heads. This is actually a binomial distribution with 7 trials. The probability of success on each trial is 0.5. And we want to know what's the probability of getting 2 successes. So I'm going to go to my calculator. I'm going to go to second distributions. And I'm talking about getting exactly 2 successes. So I'm going to go to binomial PDF. If it was like more than 2 successes or less than 2 successes or something like that, I would go CDF. But since it says exactly 2 successes, that's binomial PDF. 7 trials. P is the probability of success on each trial. Since it's a fair coin, we assume 0.5. And the next value we're looking for is 2 successes. And that should give us the answer. So 0.16 or 0.164. 16.4% would be a good answer for number 3. All right. Number 4, it is believed that 80% of the population likes bacon. This is actually kind of a multiple choice question. The answer we'd be looking for on a question like that, on that multiple choice question, would be at least 25. If you do 1 minus, okay, if you do 1 minus probability that 0 do, plus the probability that only 1 does, plus the probability that only 2 do, plus ... plus the probability that 24 do, not like bacon. That will get you the answer, right? If you knew these probabilities, you could add up all the probabilities for 0 through 24, and then that would be the complement to at least 25. Like at least 25 means 25 or more, 25, 26, 27, all the way up to 30. So if you could say, if you could find the probability of all the possibilities from 0 to 24, and then add those up and subtract it from 1, that would give you that probability. So again, that would be a strange way to word a question and answer, but being multiple choice, you should be able to find that multiple choice. Figure that out from the multiple choice. All right. Number 5, if a certain confidence interval is too wide to make useful inferences, what are some ways to reduce interval width? Well, here are some ways. You could, to reduce the interval width, you could decrease the level of confidence. That would be one way to do it. If you decrease the level of, sorry, I said that backwards. If you want to reduce the interval width, you want to close it in, you could increase the level of confidence. Decreasing it makes it wider. Decreasing the level of confidence makes the interval wider. Increasing the level of confidence makes it tighter. Another way you can make it tighter is to increase the sample size. That could also make it tighter. So those two things would be the main two possibilities that we'd want to look for there. All right, number 6. All right, I'm trying to find a 95% confidence interval for the true mean thickness of pepperonis given the mean of a sample, and given that the population standard deviation is known. So if the population standard deviation is known, remember that you do a z-interval for that. When it's unknown, you do a t-interval. So we're doing a z-interval. And so you go to, let me just start back over so you can see how I get here. You go to Stat, then click to the Tests tab and go to z-interval. So that's option 7. Inputting data. All right, sigma is given to us. Actually, I'm not inputting data. I'm inputting statistics. Sigma is given to us. It is known to be 0.09. And the mean is given as, the mean of the sample is given as 0.74. 0.74. The sample size was given as, I think it was 35, wasn't it? 35. And we want, what confidence level do we want? What does it say? 95%. Yeah, 95. So 0.95. And you calculate that, and it gives us the confidence interval. So 0.71 to 0.77 should be good enough for that. All right. So confidence interval will be 0.71 to 0.77. All right, on number 7, similar to number 6, except that on number 7, we're not given the population standard deviation. So that being the case, we don't use the z-interval, we use the t-interval when we don't know the population standard deviation. So I'm going to go to my calculator. I'm going to go to Stat. Click over to Tests, and this time I'm doing the t-interval, option 8. And we're inputting the stats. I believe the mean was 71. And the standard deviation, I believe, was 8. And the sample size, I believe, was 40, I think. Let me make sure. Yep. 99% confidence interval. So sea level is not it's not 0.095, it's 0.099 this time. And we calculate that, and we get our confidence interval. 67.8%. 0.575 to 74.425. $65.575 to what? To 74.425. Okay. Number 8. Stock picking company claims to beat the average mutual fund by at least 15%. A financial advisor is skeptical about this claim and takes a random sample of 62 mutual funds. She finds the stock picking company to beat the mean of this sample by 4%. What are the null and alternative hypotheses? So, hopefully you've watched Chapter 7 video and done the Chapter 7 assignment, but this is all about Chapter 7.1. The null hypothesis is the hypothesis that has any sort of an equality in there, like equal to or greater than or equal to or something like that. So since this company, the claim is at least 15%, that means that H naught would be that. It would be mu is greater than or equal to 15% or 0.15, we might say, because that's got the equality in it. And that would be the claim. And so that means HA would be mu is less than 0.15. And that would be our answer. And it's just whichever one has the equality in there, the equality, it has to be H naught. Okay. Number 9. The investigative journalist reports that the average age of cars on the road is 8 years. A car company research team tests the claim by taking a sample, blah, blah, blah. But basically, the question is, what are the null and alternative hypotheses? Remember, the null hypothesis has to be the equality. So since the claim is 8 years, that is the null hypothesis, because that is where the equality is. So let me put that in here. So H naught would be mu equals 8. And so HA would be mu does not equal 8. Simple as that. All right. Number 10. A research company claims that at most 17% of the American workforce misses more than 10 days of work per year. A prominent CEO tests the claim by conducting his own survey of 200 random workers, finding that 41 of them missed more than 10 days of work last year. He tests the claim using alpha equals 0.05. What is the result of this hypothesis test? All right, this is a part of Chapter 7 that we didn't have enough time to get to. This was, I think, 7.4, but I'm going to show you a way you can do it using things that we've already done. So we're talking about a proportion. Because we're talking about a certain percent of the population or whatever. 17 out of 100, that's a proportion. So the claim is at most 17%. All right. So what we can do is we can make a confidence interval, which is something we did study. So if you go to Stat, click over to Tests, You could do this with the one prop z-test, but it might be a little more confusing to you since we weren't able to go over that. So if you go to one prop z interval here, one proportion z interval. All right, the x value is how many were in our sample that said yes or no or whatever. 41 of them missed more days. So 41 would be x. N is the sample size in our sample. So we got 200 workers, so that's 200. The confidence level for us in this problem is 0.05. So your confidence level will be 95% then, 0.95. Calculate it, and here is your confidence interval. So anything from about 15% to about 26% would be in that 95% confidence interval. That is somewhere in there. So he said at most 17%. So since our confidence interval goes below 17%, then we can't reject that claim. So I think we would want to say that we do not reject, and the null hypothesis would be this at most 17%. Do not reject H naught. Now, if we had gotten something in our sample to where the 17% was not in that confidence interval, was outside of that confidence interval, then we would reject. We would have rejected H naught. We would say that our hypothesis test would suggest that more than 17% misses more than 10 days of work. So I think this is about all we can say for that one. And you can do that again with a confidence interval method. All right, number 11 is again part of chapter 7 that we weren't able to cover, but I'll show you how to do this problem anyway, and we'll use it something you already know. All right, really none of this matters much except this, the alpha equals 0.01. When should you reject H naught? This is going to be based on a z-score. You can figure out the z-score necessary to reject H naught by going to second distributions and do inverse normal. And since we're looking for alpha is at the 0.01 level, the 0.1 level, then we will do 0.1 is 10%, so that means our area is 90%, so 0.90. And so we're saying 90% is to the left of it, and that will give us our z-score. So if the z-score is above 1.28, we should reject it. It's basically all that's saying. Another way you could have done it, you could have done, instead of 0.9 and left, you could have done 0.1 and right, and it would have given you the same exact answer. So again, do the inverse normal with that alpha level, and that's all you got to do. And that gives you the z-score for which you should then reject the null hypothesis. And finally, number 12, this is something that we went over in the 7.1, section 7.1. Okay, a test is conducted. The null hypothesis states the average time is not more than 30 minutes. The test concludes that the mean exceeds 30 minutes. So the test concludes that the null hypothesis is false. But after more study, it's found that it does not exceed 30. So the null hypothesis is actually true. So we rejected a true null. If you reject a true null, that's a type 1 error. Okay, rejecting a true null is a type 1 error. Failing to reject a false null hypothesis is a type 2 error. Rejecting the truth is type 1 error. Failing to reject the false is a type 2 error. Hopefully that's something you can remember. that finishes us up for this assessment practice. Good luck on that assessment. It's multiple choice. I believe it's 12 questions. Hope you do well on it, and I'll see you again another time.